Good morning and welcome. I'm Scott Pickett from TSRI, and I'm here with Bob Hussein of Stonebranch. And this morning we'll be speaking about advancing software modernization and workflow automation. We'll be talking about kind of the state of the industry from a legacy standpoint, how people are looking at modernization, what TSRI is providing in addressing those challenges, and then talking specifically about workflow automation, which Stonebranch has offered. And we'll go through and do a demo of a modernized application that has been migrated to the cloud under new workflow technology provided by Stonebranch. I'm going to go ahead and move forward then. So TSRI is based out of Kirkland, Washington. We got hit pretty hard with the cyclone bomb a couple days ago. We have a number of our employees that are without power, but the corporation is back online, and we're good to have people kind of able to join us in this particular region. The company is also represented internationally. We have a number of different development sites and management sites around the country, over 50 partners. We're addressing over 20 countries, and we're engaged with hundreds of different customers in different projects. A real strong foundation, a technical team, been together for over 20 years, and we're leading the industry in software modernization. Deep expertise in being able to do legacy mainframe modernization, but we support a number of different legacy type of platforms, from missile defense and aircraft and air traffic control to insurance companies, banks, and the federal sector. And we've had a lot of success throughout the years in the defense industry and supporting the federal sector. I'm going to hand it over to Bob to give a little bit of the background on Stonebranch. Bob?
Yep, thank you. Bob Lemieux here from Stonebranch. I run the global sales engineering team for Stonebranch. Been here at about 13 years, been in the workload space, my entire career. A little bit about Stonebranch, right? For those of you who follow the analysts, we're recognized by Gartner this year in the Magic Quadrant up in the top right. And we're also recognized by EMA and IDC. We have a global footprint across North America, Europe, and Asia. We're headquartered in Alpharetta, Georgia. In Europe, our main office is in Athens and Frankfurt. If we go down to our enterprise customers, I think this number is increased quite a bit over the last few years. We could be well over 400. And Stonebranch, I believe this year we celebrate our 25th year. So we have 20 plus years of IT orchestration and automation, regardless if you're running a legacy tool or just running our agents to drive, some of your mainframe and distributed batch. One of the things that we're really proud of is our client retention, which is up around 99.5. The only time we lose customers is, due to a buyout or bankruptcy. So very rarely, once customers become customers of Stonebranch, they stay there. We have an active end user community. As a matter of fact, just in October, we wrapped up our Userverse conferences where they were held on site in 3 different locations worldwide, and customers in those regions could attend. It was very well taken and something we're going to continue on. And then we have a thriving partner ecosystem, which is helping to drive our technology, and all our tools that we offer in the industry. All right.
Thank you, Bob.
Yep, you got it.
So what's being seen out there by CIOs and executives in the industry is a technical debt in the legacy solutions that is associated with basically multiple different factors. In some cases, it's aging systems and kind of rigid architectures. In other cases, it's the code that's in operation is a legacy code that there's just not the human resources and modern skill sets and even SMEs that can apply. There's been a traditional underinvestment in this area as people do kind of start to develop and meet their business needs in the cloud environment. They're focused on investment in that area, and there just hasn't been the investment in any of the legacy solution, the mainframe solution. So there's a mounting debt, and it's increasing with the business needs. There's a significant cost, not only to operations, but in the ability to meet those challenges. So together with Stonebranch, TSRI is offering a solution that migrates from those legacy implementations and mainframe implementations in a kind of a graceful way. So I'll talk a bit about that. TSRI focuses on language migration from COBOL to Fortran, PL1, and we bring it into our tooling into a intermediate object model, and that allows us to operate as an expert system and be able to do different refactorings and provide different type of reports and documentation, and be able to, in the end, provide a rules-based refactoring capability that will knit into a modern language like C# or Java, and you'll see Python in this presentation. Stonebranch augments that capability with respect to its ability to not only support legacy implementation on the mainframe, but actually be able to modernize from those legacy implementations to implementations that could be hosted in the cloud and hosted on the mainframe and drive cloud technologies, and we'll be representing that. TSRI also offers a kind of a complete data migration capability and schema transformation capability. So as you do these different transformation projects, you're able to make sure that the data migration and the schema transformation and the data migration are supporting the testing and integration services. So let me talk a little bit about the tooling at TSRI. TSRI has developed over the last 20 years a Janus Studio toolset, and we fundamentally take in the legacy languages like COBOL, Fortran, PL1, and JCL, and we'll go through the standard kind of parsing and then lex it and bring it into our tooling, into a representation, a model-based representation of the syntax tree. At that point, it's constrained and then modified to be able to go into a language neutral model and in an intermediate object model. And it's that model that's actually used for refactoring. So here we'll be able to be in a position to be able to start to take advantage of native language constructs. You'll be able to reduce complexity, eliminate redundancy, find dead code, a number of different automated refactorings are applied with this rule. And it's an expert deterministic AI engine that allows for end users, not end users, but allows for our developers to write rules to be able to refactor and be able to provide those refactorings on that model. And then you'll end up in a situation where you target it towards either Java or C# and then deploy it. We also develop new gateways almost every year. There's a couple new gateways that we're offering. CIDO in assembly. I mean, a couple of examples. What we're doing now is augmenting the Janus tooling with an LLM-based solution as well in a couple of different areas. At the beginning of these projects, there's an assessment, and we want to be able. And oftentimes there are not SMEs available that really understand what the solution is doing. So from Janus, we extract out from the AST or from that the object model a knowledge graph, and that knowledge graph goes into a vector database that is then leveraged by a customized prompt engine that feeds into the LLM and gives us precise information and as I mentioned, deterministic inputs into the LLM that allow us to be able to have business documentation available that can be used in addition to a blueprinting capability for additional assessment, understanding the complexities, understanding dependencies between the different applications, and being able to put together a strategy for the overall modernization efforts. In addition to that, a big part of the projects generally are in integration and testing. And TSRI can extract out metadata from our Janus tooling to be able to understand these interfaces for external interfaces to the database, specific tables that are required, files that are required for each JCL script, and also what's required for each step within the JCL, so that you're able to put together, you're able to leverage that metadata for the development of test cases. And so we're able to augment this capability also, again, by extracting out a knowledge graph, bringing it into the LLM, and then providing a custom prompt engine to develop additional test documentation, all of which can be used to reduce that testing effort. Oftentimes, these projects don't have artifacts in testing in the mainframe environment, and these need to be developed in order to maintain functional equivalency and test the functional equivalency. TSRI and Stonebranch are engaged in a multi-phase process with respect to these modernizations. And this shows you an example of what those phases look like. The initial phase is a kind of a documentation, advisory, assessment phase, where you're going to be looking at the overall solution and all the code base and all the legacy implementations and the interdependencies associated with those legacy implementations, and begin to plan for how that is going to get rolled out with respect to a modernization effort. Here, oftentimes, you're engaged with understanding what you need to do from a workflow standpoint, from a scheduling standpoint, how you want to go through and address the jobs that are being kicked off by the scheduler, whether or not there's consolidation that's required for the overall project, and when you'll take that on. So we oftentimes kind of meet here with the customer, and that's frankly where I actually first met Stonebranch for the Danish Postal Service integration efforts that they undertook with respect to TSRI as well. The next phase is in automated transformation. As I mentioned, that tooling will emit code. That code is ready to be deployed. We have a number of different frameworks that are available and external implementation that are available. And then the code is the transformed code was made available. And we'll go through the process of doing refactorings, deployments, testing, any type of bug fixes or modifications that are required in order to meet the new deployment needs. We also apply tools. SonarQube is an example for code quality technical implementations. I'll talk a little bit about that. So that's the transformation phase. Then the next phase after that, we get into the automated testing integration. And this is primarily based on functional equivalence testing. So you'll deploy it into a typically a cloud environment. You typically deploy it as a container, and then be able to do the functional equivalency testing to make sure it's the same as the mainframe, and then continue to deploy with additional native cloud services as they replace the legacy implementations. So this is a multiple phase project. Typically, it's not the big bang approach where you just throw it all over and hope you'll integrate online, you'll do partial online deployments, then you'll migrate into the batch components. In situations we're able to interface with multiple different data repositories, you don't have to be dependent on a modernized database up front. So you have a graceful go live strategy that gets you in a position where you can support the production environment. And then you stay engaged in that production environment to be able to do continued refactoring and support. And these two areas are also two areas where we work with Stonebranch on. The integration, in the show example of that, where we integrated in two different ways, and then on ongoing support side as well. So today, we're going to be talking about one application. It's a kind of a school class reservation application. We call it the reservation application. It has both an online and batch demonstration. Because we're speaking towards the batch and the scheduler side, we'll just focus on that today. But this is an actual application run on a mainframe for one of our very, very large partners out of Europe. And it allows for users to kind of enroll in a class and see what availability they have in that classroom, make payments, and the like. It went from COBOL to a Java implementation on the back end and we've also supported C#. And we've basically deployed this in every cloud vendor, from AWS to Azure to IBM Cloud and Red Hat, OpenShift, Google Cloud, and also Oracle. So it's, we've moved this over several times. We went through the process of going through a code scan and going through a formal pipeline. And as you can see, we've made the changes required in order to have like quadruple A's as far as being able to support high level of code quality. I think that's pretty much an overview of what this particular application does. It's about 10,000, 11,000 lines of code, a couple thousand lines of JCL. We did apply a number of different refactoring, as I mentioned, and these are kind of broken down to a couple different areas. One of them is on the architecture side, where we're in the UI side, we're putting in REST interfaces to be able to support Angular. So we have kind of a scaled out presentation layer. On the database side, we inject a DAO that allows for the support of multiple different databases. So we can actually support multiple DAOs. And then we also support Spring annotations and dependency injection. It's from the modern design pattern. Again, all these are done automatically. There's a number of different language constructs that are required. The obvious one is filter elimination. But that's an important part. We have literally, in this particular application, I think there are over 160 automated refactorings applied, and the company has over 1,500 kind of automated refactorings and options that we run on our tool to be able to apply the appropriate refactoring for that legacy language or for the target. There's a number of different things with respect to consolidation and code reduction. Similar records that were consolidated, dead code analyzed and dead code removed. And then obviously, as I mentioned before, the ability to support code quality scans and be able to have a higher level of engagement. So with that, I'll go ahead and transition over to Bob to talk a little bit about the Universal Automation Center from Stonebranch. Bob?
Thank you. So at Stonebranch, we reference our tool set as the Universal Automation Center, right? It's can be centrally configured. It can operate on premise, or it can even operate in a hybrid model where we'll talk a little bit more about where it could be installed in the cloud, on premise, or even both, right? We have integrations, deep integrations across any mainframe, distributed containers, cloud infrastructure. All ours is, visual drag and drop, no to load code, creations of the flows, which you're seeing in the window over there. And if you look into that picture, you will see, a lot of the different tools that customers have. And we bring everything into really a single pane of glass to make it very visual, right? We have managed file transfer built into the tool set, and we also have B2B, which we reference as our UDM gateway for trading files with your partners, and then kicking them into your ETL processes or your data ops pipeline. The dashboards come with predictive analytics for SLAs and alerts, and even integrations into your ITSM tools like ServiceNow, PagerDuty, Salesforce, or whatever tools that you're using in-house. We have all these integrations available. If we don't have them, we can one of our engineers can put them together pretty quick and adapt them to the scheduling tool. We're real-time automation with event-based. And this is one of the things, as I mentioned earlier, I've been in the workload space a very long time. There's a lot of tools out there that work off of a 24-hour clock. We're different, where we can make things happen exactly when they're supposed to happen. So we don't have to bring, everything in at one time and try to organize them in a manner to see if it might happen or it, could possibly happen. We can make things happen when they're ready to go. We have self-service automation, uh, via any business app, and we have a very granular role-based permissions where we can leverage self-service tools. And if I'm Bob and I have the ability to run, separate different types of workloads, you can set up your security to allow that. And then, one of the major functions, what our tool is, our DevOps, or our built-in bundling and promotion, and the integration of jobs as code. So what that's basically talking about is, if I have a production schedule, I need to change it, I can move it to a lower environment, I can test it, and then move it back up. And then we have, automatic versioning, where anytime anybody makes a change to any element within the universal controller, there's an automatic version. But we also can integrate with your CI/CD tool chains, whatever ones you're using today. Again, with Stonebranch, we offer SaaS based. We've seen a 200% increase in SaaS customers over the last year to two. But you can definitely, do the tool on premise or even as a hybrid approach, which I mentioned. The nice thing with our tool set is that whether you're in the cloud or on premise, the tool functionality is exactly the same. There's nothing that's different from on premise to cloud. Okay. All right. So if we look at this slide right here, it's basically, I'll call it a high level architecture, right? Where, we're referencing, AWS, where we have the scheduler, up in the cloud, right? The universal controller is what the brains of the operation. He's the scheduling engine. He could be on obviously on an EC2 instance in AWS, or we even support Azure, Google, whatever cloud tools you're using. AWS and Azure is what Stonebranch harnesses our customers for SaaS, right? Um, and we use all the tools in AWS, as far as the Aurora, database for the controller. And then you're looking at the communication layer between, different agent, and you can see where, we drive the workload to and from the OMS, is what keeps tracks of jobs that say run this process on a EC2 instance. We grab it, he tracks it, and then he sends a status back, right? Our agents are all shipped with the Python SDK framework, which is really gives us the simplicity of building, a lot of the integrations. Even what Hussein shows you today was built off of the Python SDK process. Okay. And I believe the next slide is, kind of similar side. Yeah, except, when we do REST or API calls, we don't really need to leverage any agent technology. We can leverage REST, SOAP, SQL stored procedures directly from the controller into those environments where the processes need to go. And with our Python SDK, that needs to integrate with any cloud endpoint, we can drive it with, we call it a utility agent or a boss agent, where there's no software that needs to go on those application servers, right? We connect via endpoints. Any credentials, any certificates, or whatever needs to happen can be done, pretty easily.
And just to add, TSRI kind of offered those endpoints in our solution on the Python side, and literally integrated this in, very, very quickly. And it's a standard integration. So we're getting the job names and then executing those jobs. Those jobs are calling through, again, another REST interface to another container on the back side, and then we pass the return code for real-time status through that REST interface back to the universal It's loading.
Yep. Thank you, Rob.
Okay.
Yep.
All right. And you've got the next slide here.
So, this slide to me, means a real lot, right? Because, customers know today that anytime you change anything, right, there's work involved, right? And if any vendor tells you it's easy, then you might want to look for another vendor, right? But at Stonebranch, I've been using this express conversion tool or prior to even coming to Stonebranch, and it's modern. And as you can see over on the left, we can point it to any legacy tool. We're just showing you a drop down where we can hit any of the Broadcom tools, BMC or IBM legacy tools. And the nice thing with that is when we use the express conversion tool, we take the legacy reports out of, we'll say CA7 or ESP. We feed them into the tool, we convert it, right? And we have the opportunity to say, I have some mainframe jobs that are going to stay. They're not going away right away. But, in the case with TSRI, we can say, when I do this conversion, I want to flip it to the TSRI app, process that's going to run those Python scripts, right? And run the process through their transformation tool, right? And Hussein's going to show you that today. But by doing it like this, we're keeping all the scheduling integrity intact, right? Which means the jobs still need to run in the right order. They need to run at the right time. We need to have, monitor for failures. We need to be able to take actions. And that's what the Stonebranch tool set does really well. And I think you'll get a pretty good visual for that when we get to the live demo. Okay. All right, if you look here, it's just a sample of when we convert the task, you can see the ZOS replacement. We're setting it to TSRI. And you can see that in the bottom left, you can see where you have all your mainframe jobs, and then we're actually sending some data into cloud storage like an AWS 3 bucket, still integrating with the mainframe, right? If we move to the right, there might be situations where we still need mainframe jobs to run, but we have some scenarios where they want to modernize and go to a TSRI task, and then do the same thing, moving data to cloud storage. So basically at your fingertips, when I talked about the integrity of, the legacy schedules, this is the way that we do this, and we're very successful at it. Okay. So what I want to show you here was, basically when our mainframe task setup is done, it's done, it's very simplistic, right? We put a ZOS agent on the mainframe. We have a job. We tell it which JCL library to run from, and he runs it. We track it, get all the job logs, the system messages, anything that's pertinent to that task remains intact. When we migrate it over to a TSRI modernization task, you can see it keeps the job names. It gives us the API URL, and then the job name or the program name that we want to run, right? So by using this type of conversion process, it works really nicely for Stonebranch and the modernization tools that we use. Okay.
Yeah. Okay. Thanks, Bob. I think I want to introduce Hussein. Hussein is going to be doing a live demo showing off some of the integration efforts we've just succeeded in, and going through his tooling and some of the features. So, Hussein, if you can go ahead and kind of confirm your, there you are.
Thank you. Thank you, Scott. My name is Hussein. I'm the lead solution engineer for the Stonebranch. My background is like 20 years of development, so and I will do the demo. Let me share my screen. So this is the controller URL. So this is the web interface of the controller. So we have two different integration for TSRI. So based on the conversion, and it can be a Python integration, or it can be an API integration. So when it's a Python integration, so it means that the code is converted to a Python, then we need to run this Python code. If it is an API interface, we run the API code and to run it. So I prepared a workflow like this. So this workflow is like the hybrid environment, because you may have some modernized task, but you may still have something on mainframe. You may need to transfer some files, or you may need to execute something on your existing mainframe. You may have some modernized tasks, so you can use them in the same workflow. So in this example, for example, we are starting with a mainframe task. So just let me show you what mainframe task means. It is we have a mainframe agent installed on mainframe, and we are saying that run this JCL file. So once this task is completed, it will give us an output. And once this task is successfully completed, then we will run this TSRI task. So this is an API integration. So when we say an API integration, so we have these functionalities with the API. So we can start a job, we can stop a job, or if a job is failed, we can restart it. We can also get the status of the job, and we can get the logs. So this start will do all of them. Start will start the job, and it will check the status continuously until the job is completed. Once it's completed, it will get the logs. So to be able to execute that one, we need to give the API endpoint. And we have two security options here. One of them is like a OAuth token, and the other is a server base, which is just checking the IP address of the source. And then the rest is we just need to give the program name. So based on this one, API will start the program. So if you want to overwrite the program name, like for example, if there's an error or something, you can overwrite it. We have this option. And by default, we are waiting for this task to be completed. But if you just run and forget, you can also do that. But this is the recommended one. Then we continuously check the status of the task. And at the end, we fetch logs. So you don't need to go the other system to check the logs. You can easily see them in here. And same thing for the Python. Python is a little simpler, so you just need to give the name of the Python. But the good thing is you can use some variables. For example, here I have a job name like this, and it will automatically get the job name and put it here, and it will find the Python code, and it will execute that one. But the way it works is very similar. The only difference is like with the Python execution by Python integration, you need to have an agent on the same server. With the API, you don't need. API, we just need, we will remotely connect to the API endpoint. So creating a workflow like this is really simple. So I will show you, for example, I have another task here. So if you want to modify this workflow, if you want to add a new task, for example, you can just edit here. And if you want to put a connection, say that after this task is completed, I want to run that task, then it's that simple. Once I save that one, then we change the logic of the workflow. So now let's launch it. So I will launch the workflow. So in this case, if I go here, and let's see if I refresh that one. Okay. So this is the workflow instance. So when it's executed, we have a copy of it like an instance. So for the demo purposes, I make this task like a on hold. I will release that one. So it will first run the mainframe task. You see all of them are waiting for it. So once this task is completed, I can simply see the output, for example, of this task. So in here, you see in the mainframe task, I can able to see what happened. Like I can see the status of each step. I can see the logs of each step. It is very similar with the TSRI task also. If I retrieve the output, or let's do this one first. If I double click on it, I can able to see what is the job ID, what is the status of the job, what is the program name, what is the data that come from that. But if I go to the output, if I retrieve the output here, I will see the similar output. So this is the execution output, but this is the output from TSRI, so mainframe modernization project. And I can also see the same thing. I can also see the details of each step I can see the output and all of the information about the steps here. So I have a task failed on purpose here. So you see here, when a task fails, the dependent tasks are waiting for it. You have two options. You can let's see the error. Let's double click here. I see that it failed, this is the exit code coming from the API. And I can see the job number, I can see it failed. And this is the message coming from the API saying that step 30 failed with exit code 256. And if I go to the output, I can also see the output. Like if I see the output of the step 30, which is here, I can able to see that there's a return code, this one, and I can see the details, what happened and why we get this error. So now I have, as I said, I have two options. One option is I can fix this one. So for example, I can use an override library here. And I can say that instead of running that one, run this code. Or if you have another program that fixed that problem, you can also run that one. Or you can force finish. Force finish means that I will not continue. I will do it manually, but I want to run the rest of the process. But this time I want to override it. I saved it. I right click on it and then I rerun it. So when it reruns, it will rerun with the override library. Then it will use the other program. Now it's successfully completed. Then the rest of the process is executed. And one interesting thing here is I can still see the output. So you see this is the output of the second attempt. I still have the output of the first attempt. This was the first execution, and I have the output of the second execution. So if you fix something, if you change something, you can also have a history of the output. Okay, that's all my demo. We are back to you, Scott.
Thank you, Hussein. So I want to go ahead and summarize here. What you've seen is both a modernized application, modernized job flows, and also modernized integration points. And then you've seen also the ability for that modernized solution to be leveraged on a legacy mainframe platform, or be able to be brought over into a cloud environment. So, some of the benefits associated with that, approach and TSRI modernization are associated with many of the benefits you get when you migrate over to the cloud environment, with respect to maintainability improvements, with respect to being able to have modern design paradigms, as we've shown, the ability to support REST APIs for real-time integration capability, being able to deploy in a modern way, using a modern pipeline. We didn't show that pipeline, but let's just do a standard CI/CD type of pipeline, allowing you to change it very, very quickly, and be able to provide new integration points and new refactorings, and be able to support additional code quality capabilities as well. We're able to put in those REST endpoints that allow for integration with the scheduler, but we can put in REST endpoints to also allow for integration with other type of native service in the cloud environment. And talk briefly about some of the other capabilities that TSRI provides as far as integration with an LLM, and its GenAI offering, and also its testing services. So I think that was what we planned to discuss. I did want to see if there was an opportunity to answer any questions. And if not, I think that is it for our presentation. Thank you very much for your time. For those of you that were hit by the storm, glad you could make it. And for those of you out there that hope everybody's doing well and have a great day. Rob, did you want to end with anything, or Hussein?
Nope, that was it. Thank you, Scott, Bob, and Hussein. We appreciate your time, the demo, and all the work you put in. This is great information, and we'll be sure to reach out to those who joined and share the recording with those who couldn't make it. So thank you very much, everybody. Have a great day and a great holiday next week.
Thank you.
Thank you.
Thank you.